Hello friends, first of all thank you for taking the mock test. In this video let us discuss the solution of mock test third.
So in this video we are going to discuss 25 questions. So here you have to enter the email address. So first question what they have given is the intersection of asymptotes of root loci of a system with open loop transfer function g of s into h of s which is equals to k divided by s into s plus 1 into s plus 3 is.
So this is the question. What they are asking is they are asking us to find intersection of asymptotes. What do you mean by intersection of asymptotes means we have to find the centroid. So this problem is based on root locus. So how to calculate centroid? Centroid is given by sigma which is equals to summation p minus summation z whole divided by p minus z. So in the transfer function you will be having poles on the denominator and you are going to represent zeros in the numerator. So the pole location is at 0, minus 1 and minus 3. There are none zeros. So it is summation p. So it is at 0, minus 1, minus 3. So this is at poles. How many zeros are there? There are none zeros and the location is we don't know. So I am taking it as 0. What is p minus z? How many poles are there? There are 3 number of poles and there are none zeros. So it is 3. So I will be getting minus 4 divided by 3, that is sigma which is equals to I will be getting minus 1.33. That is option number D. That is option number D.
Second question, the best technique to find relative stability is we are going to make use of root locus. We know that in the case of absolute stability we are going for RH criteria, but for relative stability we are going to make use of root locus, Bode plot and Napier's plot. Among this the best technique is root locus. Third question, identify the strongest bond. So we are having ionic bond. This ionic bond is nothing but a complete transfer of electrons. Say suppose if I am considering NaCl, sodium is going to give away the electron but chlorine is going to take the electron. So it is complete transfer of electrons. In the case of covalent bond, it is sharing of electron. We know that always sharing creates a problem. In the case of metallic bond, pool of electrons will be forming a bond. Van der Waals bond, it is a weak bond. You can find in graphite. Hydrogen bond is also a weak bond. So the answer is ionic bond. Ionic bond is the strongest bond. Balance modulator is used in. This balance modulator you can call by other name as product modulator. So this balance modulator is used in double sideband suppressed carrier. It is not used in AM, it is not used in FM, it is not used in either in SSB or in VSB. So the suitable option that is going to follow is option C, that is double sideband suppressed carrier or double sideband. Next question, we need to calculate the dynamic power dissipation in the case of CMOS transistor given operating wavelength equals to 30 cm, load capacitance equals to 0.1 micrometer and is powered by 7 volts, 0 volt supply.
In this question what they are asking is we have to calculate dynamic power dissipation in the case of CMOS. We know that the static power dissipation is approximately equals to 0, but if I am talking about dynamic power dissipation, the dynamic power dissipation is given by P dynamic which is equals to FCL VDD square. Now what is frequency? We have to derive from operating wavelength. We know that F equals to C divided by lambda. Since they have expressed lambda in terms of centimeter, so let me express the speed of light in centimeter, nothing but which is equals to 3 into 10 power 10 divided by 30. So what I am getting F as 1 giga, nothing but 1 into 10 power 9. So let me substitute over here. So I will be getting 1 into 10 power 9 into what is the value of capacitance they are given? It is 0.1 micro. So it is 0.1 micro into what is the value of VDD? It is 7. What is 7 square? I am getting 49. Right? So it is 10 power 9 into 10 power minus 6 which will be 10 power 3. And again point is there. This point if I am shifting to 49, I will be getting 4.9 kilowatt which is approximately equals to 5 kilowatt. That is option number B. So I got dynamic power which is equals to 4.9 kilowatt. If I am rounding off, I will be getting 5 kilowatt which is option B. So this is how we are going to calculate dynamic power dissipation. If they are talking about static power dissipation, straight away you have to tell it is approximately equals to 0.
Next question, for displacement measurement, which instrument is preferred? Wheatstone bridge, shearing bridge, LVDT, Megger instrument. We know that for displacement measurement, we are going to make use of LVDT because the sensitivity is 40 volt per millimeter. Nothing but for every 1 millimeter displacement, you will be getting a voltage of 40 volts. So it is LVDT, linear variable displacement transducer. Next question, calculate the radiated power given carrier power PC equals to 100 watts and the square signal modulated by 70%.
This problem is based on amplitude modulation. What they have given is, they have given the carrier power which is equals to 100 watt and the modulation index which is equals to 70%, or I can write it as 0.7. Now what they are asking is, we have to calculate the total power, but the carrier is square or rectangular. When the carrier is square or rectangular, what is total power? Total power is given by PC into 1 plus mu square. When you are going to write by 2, when it is sinusoidal. When you are going to write by 3, when it is triangular. So I am getting carrier power which is equals to 100 into 1 plus, what is 0.7 square? So I will be getting 0.7 square which is equals to 0.49. So I will be getting 100 into 1.49 which is equals to 149 watts. So I will be getting radiated power or total power which is equals to 149 watts. That is option B is going to follow. That is option B is going to follow. This is very important. When it is sinusoidal, when it is square or rectangular, and when it is triangular, this kind of questions they will be asking.
For increasing the voltmeter or ammeter range, we make use of varactor diode, swamping resistor, insulators in series or parallel, semiconductor materials. We know that for increasing the voltmeter or ammeter range, we are going to make use of swamping resistor, which is made up of manganese. In order to increase the range of voltmeter, we are going to connect the swamping resistors in series, and in the case of ammeter, we are going to connect in parallel. Only the drawback in the case of the swamping resistor is the sensitivity decreases, right? But range get increased. So always there is a trade-off between sensitivity and range. In the case of intrinsic semiconductor, as temperature increases from 0 Kelvin, electron concentration will be equals to hole concentration. Nothing but for every change in temperature, you will be getting an electron as well as hole. So if you are capable of generating 5 extra electrons, similarly at that point of time you will be getting 5 extra holes. Nothing but hole concentration and electron concentration will be the same in the case of intrinsic semiconductor. But it is not the scenario in the case of extrinsic semiconductor. If it is N type, then you will be getting more electrons. If it is P type, then you will be getting more holes. Next question, what is the time required to reach 2% of the steady state value for closed loop transfer function when the input is u of t, that is 2 divided by s plus 10 into s plus 100.
Now in this question what we have to find is, we have to find the settling time. So they have given the transfer function which is 2 divided by s plus 10 into s plus 100. Now we know that the poles are at s equals to minus 10 and s equals to minus 100. So s equals to minus 10, this is a significant pole, and s equals to minus 100, which is insignificant pole. So I can neglect this s equals to minus 100 pole. But straight away I can't neglect. I have to maintain the gain properly. So which is 2 divided by, let me take 100 as common. So I will be getting 100 into s plus 10 into 1 plus s divided by 100. So this term I can neglect now. Able to follow? So I am getting 2 divided by 100, which is equals to 1 divided by 50. Again let me take 10 as common. So upon taking 10 as common, I will be getting 0.1 s plus 1. So this one I need to compare with the standard form. that is K divided by S tau plus 1. What is K? It is gain. So the value of K, which is equals to 1 divided by 500, and what is the value of tau? Tau equals to 0.1. Tau equals to 0.1. Now, in order to find the settling time Ts, which is 4 tau for plus or minus 2%, so upon solving I will be getting 0.4 second. 0.4 second, which is approximately equals to 0.2 second. Nothing but option C is going to follow. Able to follow? Now, whenever they have given the transfer function, please make sure that you need to talk about significant pole and insignificant pole. And when you are eliminating the insignificant pole, you have to maintain the gain as constant. So this is very, very important. So this kind of questions you will be expecting in GATE exams.
Which of the material exhibits highest resistance? BJT, DTL logic family, MOSFETs, JFETs. MOSFET resistance is in the order of giga. Even JFET resistance is also in the order of giga. But if I am comparing JFET resistance with MOSFET resistance, JFET resistance is more when compared to MOSFET resistance. So here I am speaking with respect to input resistance. Next question, calculate the conversion time of 20-bit SAR, assume clock frequency equals to 1 megahertz. So here what they have given is clock frequency equals to 1 megahertz.
So in this question what they are asking is, we have to find the conversion time in the case of successive approximation register type. But what is the frequency they have given is, they have given the frequency as 1 megahertz. Now, what is the conversion time in the case of successive approximation register? It is n times of t clock. It is n times of t clock. Now, we have to know the conversion time of counter type, flash type, successive approximation register type, as well as dual slope or integrating type. So in the case of successive approximation register type, the conversion time is n times of t clock. What is n? So the value of n is 20 into what is t clock? It is 1 divided by f clock. Nothing but operating frequency, which is 20 divided by what is f clock? It is 1 mega. So I will be getting the conversion time, which is equals to 20 microsecond, which is 20 microsecond. That is option number C is going to follow. Able to follow, friends? You have to know the conversion time of counter type, flash type, successive approximation register type, dual slope or integrating type. So these things are very, very important.
Which A to D converter, next question, which A to D converter takes large conversion time? Counter type, flash type, successive approximation type, dual slope or integrating type? For this the answer is dual slope or integrating type. In the case of generation of modulated signal, a varactor diode can be used for FM generation only. What do you mean by varactor diode? Diode followed by a capacitor. So in order to tune or in order to get range of frequencies, you can tune either inductors or capacitor, but tuning inductance is a tedious task. So what you are going to do is you are going to make use of a capacitor. Power spectral density of a white noise is.
So the question what they are given is power spectral density of white noise. So if I am talking about power spectral density of white noise, so what I will be getting is, so this is with respect to frequency. If I am plotting, this white noise will affect each and every frequency component uniformly. So it is like this. So it's a straight line with amplitude of n0 divided by 2. So this is very, very important. Hence, the suitable option that is going to follow is option A is correct. Nothing but white noise is going to affect each and every frequency components uniformly.
Lattice scattering effects at low temperature, medium temperature, 0 Kelvin and high Kelvin.
If I am talking about scattering or loss, you will be having two types of scattering. The first one is impurity scattering and the second one is lattice scattering. With respect to temperature, if I am plotting, you are going to plot with respect to log of temperature, you will be getting a curve which is something like this. Which is something like this. So you will be getting a scattering loss, that is lattice scattering over here. But this is impurity scattering. This is impurity scattering. So I am plotting loss versus temperature. Now, if you are considering this one as moderate temperature, so lattice scattering will be affected at high temperature.
Next question, 13 dBm is equivalent to 2 milliwatt, 20 watt, 20 milliwatt, 2 megawatt.
Now in this question what they are telling is 13 dBm is equals to, so 13 dB milli, which is equals to, they are asking. Now we know that power in dBm, which is equals to 10 log of power divided by 1 milli. So this is how we are going to express in terms of dBm. So this is 13, which is equals to 10 log of P divided by 1 milli. P divided by 1 milli. What is 13 divided by 10? Which is 1.3, which is equals to log of P divided by 1 milli. So in order to cancel this log, what I am going to do is 10 power 1.3, which is equals to P divided by 1 milli. So what I am going to do is I am going to send this 1 milli over here. So this is P. So the answer what you will be getting for this one is 20 milliwatt. 20 milliwatt, that is option C is going to follow. So whenever they are expressing in terms of dBm, you should be very much careful. And if it is voltage, then you have to take it as 20 log. If it is current also, you have to take it as 20 log. Whenever they are talking in terms of power, you have to take it as 10 log of. So this is very, very important.
For oscillator design, we make use of positive feedback, negative feedback, either positive or negative feedback, neither positive nor negative. We know that for oscillator design, we are going to make use of positive feedback. For amplifier design, we are going to make use of negative feedback. So you should know what are the advantages of using positive feedback and what are the advantages of using negative feedback. So these things you should know. In the case of positive feedback, if your amplifier is producing a phase shift of 180 degree, then your feedback part should be producing a phase shift of further 180 degree, so that the total phase shift around the loop should be equals to 0 or 360 degree. But in the case of negative feedback, if you are using, you can able to achieve more bandwidth, more input resistance, less output resistance or impedance, but only the thing is you will be getting a gain of a very low value. In a certain oscillator, if gain equals to 50, the attenuation of the feedback circuit must be.
This question is very, very important. They have given the gain which is equals to 50 and they are asking the feedback factor, that is beta equals to question mark. We know that the condition for Barkhausen criteria A beta should be equals to 1. Practically, if I am speaking, A beta should be slightly greater than 1. That means you will be taking A beta equals to 1.02 roughly. So what is A value? It is 50. Nothing but feedback gain is beta and forward path gain, nothing but amplifier gain is A. Overall loop gain should be equals to 1. So 50 into beta, which is equals to 1. So I will be getting feedback factor, that is beta, which is equals to 1 divided by 50, that is 0.02 I will be getting.
And or logic is similar to NAND representation, NAND NOR representation, and or representation or and representation.
So in this question what they have given is and or is equivalent to. So in order to explain this and or, what I am going to do is I am going to make use of two level representation, right? So this is an AND gate and I am going to make use of one more AND gate. So this is connected to an OR gate. So this is connected to an OR gate. So let me take my inputs as A, B, C and D. So what is the output I will be getting is AB plus CD. So in order to make use of only NAND gate or NOR gate, what I am going to do is I am going to introduce two inverters. two inverters. Is there any problem? No, right? I am going to introduce a buffer. Now, what is AND followed by a NOT gate? What is AND followed by a NOT gate? It is NAND gate, right? So you will be getting a NAND gate. So you will be getting a NAND gate. And here also you will be getting a NAND gate. Now, what is bubbled OR gate? It is NAND gate, right? Bubbled OR gate is NAND gate. So, AND OR implementation is NAND implementation or NAND representation. This is very important. OR AND is similar to non-OR representation. So, this kind of questions you can expect in UGC NET exams.
To implement XOR gate using CMOS design, we are in need of how many transistors? Assume all literals are available. 4, 6, 8, 10.
So this question what they are asking is, in order to implement XOR, how many transistors are required in the case of CMOS logic circuits? We know that CMOS will be always, you will be getting, in the case of CMOS, you will be getting always complementary functions. So in order to realize this XOR gate, what I am going to do is, I am going to make use of XNOR complement. XNOR complement. And one more thing what they are given is, all literals are available. If I am assuming my inputs as A and B, then I will be getting A bar and B bar which is readily available. So to realize A bar, I don't require one more transistor or one more inverter circuit. So what I am going to do is, I am going to implement XNOR. What is the truth table for, or what is the logic function of a XNOR? It is AB plus A bar B bar, the whole bar. Now, in order to realize with the help of CMOS circuit, what I will be having is, I will be having a VDD rail and I will be having a ground rail or VSS. Ground rail or VSS. Here I am going to tap output, that is Vout. Now, in order to realize this AB, I am in need of two transistors, that is A and B. So this is B input and this is A input. Plus means I have to connect in parallel, that is A bar plus B bar. A bar into B bar. Able to follow? So in the case of pull down network, in the case of NMOS, dot means it is series, plus means it is parallel. In the case of PMOS, it is exactly reverse. In the case of PMOS, it is exactly reverse. A and B, here it is in series, here you have to write it in parallel. Here you have to write it in parallel. So what you will be getting is A, and here you have to give B input. Since it is in parallel, here you have to replicate in series. Here you have to replicate in series. So this kind of questions they will be asking in UGC NET exams. Make sure you will not be writing this option, or you are not going to choosing the option as 10. So most of the persons what they will be doing is, they are going to implement XOR, but they will be getting a complement. So again they are going to make use of NOT gate. Thereby you are going to make use of extra two transistors, which is actually not required. So implement XNOR. Anyway, the CMOS itself is giving a complement. That means you will be getting a XOR gate. So how many transistors are required? 4 over here, 4 over here. Total number of transistors is 8. Nothing but option C is going to follow.
Always inverse root locus starts from 0 and ends at pole. But in the case of root locus, it starts from pole and terminates at 0. This is very important. The root locus plot of a system having the loop transfer function g of s into h of s, which is equals to k divided by s into s plus 1 into s square plus 4s plus 3, as it will be having 3 real breakaway points.
So in this problem what they are given is, we need to calculate breakaway points. How many valid breakaway points are there and where are they situated? Now in order to calculate the breakaway point, so you will be getting, say suppose if you are getting some 2 or 3 breakout points, it should be a valid breakout point, nothing but it should lie on root locus. How we are going to calculate the breakout point, friends? Let me take this one as dk divided by ds, which is equals to 0, nothing but this entire term you are going to take d by k whole divided by s into s plus 1 into s square plus 4s plus 3, which is equals to 0. K you are going to take it as 1. Now that is d into 1 divided by s square plus s into s square plus 4s plus 3, which is equals to 0. What is s square into s square? It is s power 4 plus 4s cube. Again you will be getting s cube over here, that is 5s cube plus 3s square plus 4s square, which is 7s square plus 3s, which is equals to 0. So it is d into 1 divided by this entire term you are going to write, that is s power 4 plus 5s cube plus 7s square plus 3s, which is equals to 0. Make use of u by v formula. So what you will be getting is 4s cube plus 15s square plus 14s plus 3, you will be getting, or you need to equate it to 0. Upon solving, you will be getting s equals to, so 3 real roots you will be getting. So this kind of problems, in order to solve, you need a calculator. But in the case of UGC NET exams, you will not be provided the calculator. So this kind of questions you can't expect in UGC NET exams. But simple problems they may ask. S into s plus 1 whole square into s plus 2. This kind of questions they can ask, where you can solve the roots easily. So those kind of questions they will be asking. This kind of tedious questions they will not be asking. So this question, how you are going to solve is with the help of pole location. So I am going to plot sigma versus j omega. Sigma versus j omega. Now look at over here. If all the poles are on the left of a first plane, then the system is a stable system. If at least one pole is on the right of a first plane, then you can tell the system is an unstable system. If you are having a simple pole at origin, nothing but a single pole, then it is marginal stable system. Poles on the imaginary axis, then also the system is a marginal stable system. A repeated poles on imaginary axis, then the system is an unstable system. So first option what they are given is -1 plus or minus j, right? So the system is a stable system. Now if I am talking about -2 plus or minus j2 and plus or minus j3, so the poles are at, now the poles are at -2 plus or minus j2, -2 plus or minus j2. So I will be getting one pole over here and one more pole is on plus or minus j3. One more pole is on plus or minus j3. So you are having a pole on the imaginary axis, then the system is a marginal stable system. Now if I am talking about -1 plus 1 plus or minus j1. So one pole is on the right of a first plane, then I can tell the system is an unstable system. So option that is going to follow is option third is going to follow.
The percentage saving power in the case of DSBSC system modulated at 80% is.
So in this question what they are asking is, we have to find the percentage saving power in the case of DSBSC. The modulation index they have given it as 80%. Now what is percentage saving index? That is efficiency, which is equals to, in the case of DSBSC you are going to save the carrier power divided by the total power. What is total power? Which is equals to PC divided by, what is total power? PC into 1 plus mu square whole divided by 2. Make sure by default it is a sinusoidal one. So whenever it is a sinusoidal, it is 1 plus mu square divided by 2. Whenever it is square or rectangular, it is 1 plus mu square. But whenever it is triangular, it is 1 plus mu square whole divided by 3. So I can cancel this PC term. So what I will be getting is 1 divided by 1 plus mu square. What is mu square? It is population index is 0.8, right? What is 0.8 square? Which is 0.64 all divided by 2. That is 1 divided by 1.32, or I can write it as 100 divided by 132. So I will be getting 75.757, which is approximately equals to 75.76%. So this is how you want to calculate efficiency or percentage saving power. So this is very important. So if they are asking with respect to single sideband, at that time you have to include one LSB or you need to include one MSB. Nothing but lower sideband or upper sideband, USB, right? So this is very important. If they are talking about vestigial sideband, what you are going to do is PC plus P delta, nothing but one vestige you are going to take. So this is how you are going to calculate the percentage saving in the case of DSBSC, SSB and VSB.
So upon finishing with the test, what you have to do is you have to click on this submit. Once you clicked on the submit, what you have to do is you have to click on the view score, so that you will be getting the actual score. Which question is correct, which question is wrong, you will come to know. Since I have framed the mock test and have taken the mock test, my score is 50 out of 50. So this is how you can take the mock test. Keep taking the mock test, improve yourself. Don't get stressed or don't get demotivated upon taking mock test, and if you are scoring less marks.
So friends, in this video we have discussed the solution of mock test third. If you have followed the lecture, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.